Hey, very good morning, students. Let us look into our very next topic, designing a synchronous counter. Synchronous counter design is a very important question. We are going to design a 2-bit counter using JK flip-flop. There are 5 steps for designing a synchronous counter. The first step, any counter, any synchronous counter design, either it is 3-bit or 4-bit or 2-bit, using any flip-flop JK or T or D, the steps for designing a synchronous counter remain same. The first step is you need to identify number of bits and number of flip-flops. Let us start with step 1. What is my first step? I need to identify number of bits. So how many bit counter was asked to design? 2-bit counter. So number of bits is 2. So n value is equal to 2 bits. Then we need to understand what flip-flop we need to use to design this counter. It is given in the question 2-bit synchronous counter using JK flip-flop. So I'm going to use 2 flip-flop as what? JK. Since there are 2 bits, you need 2 JK flip-flops to store the data, right? So I now what is that I understand from step 1? What is the value of n? N is number of bits. Since it is given in the question 2 bits, I need to write it as 2. And what type of flip-flop I'm going to use? In the question they have asked you to design using JK flip-flop. That is why I've used JK flip-flop. If it is T, you need to use T flip-flop here. Clear? Now how many flip-flops I need to use? Number of bits is 2, so I need to use 2 JK flip-flops. That is done. Let us get into the step 2. Write the excitation table of the flip-flop. So what flip-flop you are going to use? JK flip-flop. So you need to write the excitation table of JK flip-flop. Okay, this is step 2. After writing the excitation table, can you see this is the excitation table of JK flip-flop. What is the step 3? You need to draw the state diagram and tabulate the state table. That is your step 3. Step 3 is you need to make state diagram and state table. Let us see how to draw the state diagram. When it comes to state diagram, you know what type of counter you need to design. You need to design 2-bit synchronous counter. Since it is 2-bit, it is 0 0 0 1 1 0 1 1. So state diagram is nothing but pictorial representation of the behavior of the sequential circuit. So since it is counter, it counts from 0 0, then it goes to 0 1, then 1 0, then 1 1 1 1 back to 0 0. So this is the state diagram. In the exam, if they asked you to design 3-bit synchronous counter, then in the place of 0 0, you need to write 0 0 0, right? 2 to the power of 3 is 8 combination. So 0 0 0 0 1 0 1 0 till you get 1 1 1. So that would be 3-bit synchronous counter. Since this is a 2-bit, you can draw it as 0 0 0 1 1 0 1 1. This is called a state diagram. Now let us get into the state table. State table is nothing but it contains the information in the state diagram is transformed to state table. So what is that we are going to do? We are going to transform the information of the state diagram into a state table. Listen very carefully here. So you should know what is the state. Can you see this state? This is the present state 0 0. What is the next state from 0 0? Next I will go to 0 1. So if present state is 0 0, next state is 0 1. Clear? So Q0, Q1 represent present state, Q0 star and Q1 star represent next state. If I am in 0 0, can you see if I am in 0 0 present state, I will go to 0 1 for the next state. If I am in 0 1 in the present state, I will go to 1 0 in the next state. If I am 1 0 in the present state, I will go to from 1 0 I will go to 1 1 in the next state. If I am in 1 1 in the present state, I will go to 0 0 back to the next state. That is what you are going to transform this diagram into a table. 0 0. First you need to start with present state 0 0. From present you are going to next state. So 0 0 to 0 1, 0 0 to 0 1. Now 0 you are in this state. From 0 1 will become present. You will go to next 1 0, right? So finish this one. So Q0 Q1 is present. Q0 star Q1 star is next state. Now, why we have taken excitation table? You should ask me. Step 2, you need to write the excitation table, right? From the excitation table, you are going to fill the inputs of JK flip-flop. How many JK flip-flops we are going to use? If n value is 2, it means I'm going to use 2 JK flip-flop. flops. So this is my first JK flip flop, J naught K naught. This is my second JK flip flop, J1 K1. Now I need to fill the data inside this JK flip flops. Now this how do I fill is based upon the excitation table. Now how will I do it is I have the excitation table here. Now what is that I need to see? If Q naught is 0, Q naught star is 1. Can you see? If Q naught is 0, you need to look like this. Q naught, if present state Q naught is 0, next state Q naught star is 1, Q naught is 0, Q naught star, present state is 0, next state is 1. What is J and K value? 1 and don't care. So what is J and K value? 1 and don't care. So J naught K naught goes for Q naught Q naught star. J1 K1, you look into Q1 Q1 star. Am I clear to you? So first let us start with J naught K naught. Means since 0 flip flop we are using, I need to see Q naught and Q naught star. So 0 1, 0 1 means 1 star, 1 cross mark or don't care. Next, what is 1? Q naught is 1, Q naught star is 0. 1 0 means don't care, 1 don't care, 1. Next is 0 1, 0 1, that is 1 don't care, 1 don't care. Next is 1 0, 1 0, don't care, 1 don't care, 1. I'm done with J naught K naught. Now come to J1 K1. How will you fill J1 K1? I need to see what? Q1 Q1 star. J1 K1, I need to see Q1 Q1 star. If Q1 is 0, Q1 star is 0, 0 0. What is the output? 0 and don't care. 0 and don't care. 0 1, 0 1 1 don't care, 1 don't care, 1 1 1 1 don't care, 0 don't care, 0. Finally it is 1 and 0, 1 and 0 don't care, 1 don't care, 1. So what is that you have done in state table? You have written the present state, you have written the next state, and two flip flops JK0 and JK1. For JK0 I need to check Q0 star. JK1 I need to set Q1 star, right? I need to check this and fill this table. Once I'm done with this table, can you see I'm done with 3 steps? Finally, fourth one is solve the Boolean expression. How will I solve the expression? This is the table which I've generated. From this, I need to solve what is J1, what is K1. I need to find the expression for J1, K1, J0 and K0, right? Since it so how I will do it? I need to consider two variables. What are the variables I need to consider? Don't forget, you need to consider only present state Q0 and Q1. Since it is two variable, draw a two variable K map Q0, Q1, 4 cells. Okay. Now what is J1? 0 1 cross cross, 0 1 cross cross. Next up, what is K1? Cross cross 0 1, cross cross 0 1. What is J0 again? 1 cross 1 cross, 1 cross 1 cross. What is K0? Cross 1 cross 1 cross 1 cross 1. Now let us start grouping. So these two are neighbors, group it. So what is common? Both belong to 1. 1 means what? Q0. So J1 is equal to Q0. Now come here. So group this 1 and don't care. Don't care here we will treat it as 1. So what is common for it? Q0. So J1 and K1 both are Q0. Now come here. If you see this, I can group this 4 because these two are considered as 1. You know, don't care can act either as ones or zeros. So take the help of don't care and group it. When I have all the cells are grouped together, then the output will be 1. Here again all the cells are grouped together, output is 1. Now what is that we have identified? J1 is Q0, K1 is Q0, J0 is 1, K0 is 1. Now draw finally last step. What is the last step? Make the circuit. So how will I make the circuit? How many flip flops I need? 2 flip flops. J flip flop, J0 flip flop, K0 0 flip flop and 1 flip flop. So JK inputs JK, outputs Q0 Q0 bar, J1 K1 Q1 Q1 bar. So this is the flip flop, 2 flip flop, 0th flip flop, first flip flop. What type of flip flop I'm using? JK flip flop. So J0 K0. What is the output? Q0 Q0 bar. Now come here. J1 K1. What is the output? Q1 Q1 bar. So since it is a flip flop, you need to give a clock. So clock is given. Done. All the inputs. Can you see first flip flop? J J naught, K naught. What is the input? J naught is 1, K naught is 1. Can you see you have derived it? J naught is 1, K naught is 1. So J naught and K naught is given to 1. Done. What is J1? Q naught. So to J1, Q naught should be connected. So Q naught is input of what? J1. What is the input of K1? Q naught. Again, Q naught is given as the input of K1. So this is the circuit for what? JK flip-flop synchronous 2-bit counter. Okay, so what is the step? First, you need to identify number of bits. Then you need to identify number of flip-flops. Then you need to write the excitation of JK flip-flop. From this, draw the state diagram. Transform the state diagram to state table. After transforming to state table, find the Boolean expressions, values for J1, K1, J0, K0, and then finally make a circuit. This is a 5-step process to design a synchronous counter. If they ask design a 2-bit synchronous up counter, listen, up counter. When I say up counter, it means 00011011. If I say down counter, then it should start like this. It should start with 11. It should go to 10 from 1001 from 0100 from 00 to 11. So that would be for down counter. But this whole presentation is about 2-bit synchronous up counter, where we move from 00 to 01, 101 to 10, 10 to 11. Okay. Thank you.